$6 million. That's all it took for a small Chinese company to build an AI that's making Silicon Valley giants nervous. For context, that's about what Meta spends on AI development in a single day.
The efficiency is staggering when you think about it. We're talking about a startup achieving with a tiny fraction of resources what took billions for companies like OpenAI.
And here's what makes this story even more fascinating. They did it while facing US sanctions specifically designed to prevent Chinese companies from competing in advanced AI.
You know what's really interesting about DeepSeek? They're not just some flashy startup making big claims. They've actually open sourced their research so anyone can verify their results.
Let's break down exactly what they've accomplished. They've created an AI model that matches or even exceeds ChatGPT's performance on many benchmarks. And they did it in just 2 months.
That timeline is incredible. How did they manage to move so quickly with such limited resources?
Well, it comes down to this fascinating workaround they developed. Before US sanctions hit, they managed to stockpile about 10,000 NVIDIA chips. But here's the clever part. Instead of just throwing computing power at the problem like their Western competitors, they had to get creative.
So they turned their limitations into an advantage. It's like being forced to cook with limited ingredients and discovering a better recipe in the process.
Exactly. They developed this innovative approach called mixture of experts structure. Imagine having a panel of specialists instead of one generalist trying to do everything. If you ask about geography, it only activates the geography expert, rather than consulting every possible knowledge base.
That's so much more efficient than the brute force approach we've seen from other companies. It's almost like they've built a more intelligent form of intelligence.
And the impact has been dramatic. When this news broke, NVIDIA's stock dropped 15%. We're talking billions in market value vanishing overnight. Wall Street suddenly realized that maybe throwing massive resources at AI development isn't the only path forward.
The timing of this is particularly interesting, especially with all the recent discussions about AI's environmental impact. I mean, Meta was literally considering building a nuclear power plant just to power their AI operations.
Right. And here's DeepSeek showing you can achieve similar results while using a fraction of the energy. It's forcing everyone to rethink their assumptions about what's necessary for AI development.
The reaction from Silicon Valley has been fascinating too. Some executives are trying to dismiss DeepSeek's claims, while others are clearly rattled by the implications.
You know what's really telling? The company is based in Hangzhou, this emerging tech hub near Shanghai that most Americans have never heard of. It's like China's version of Silicon Valley, but with a completely different approach to innovation.
That reminds me of how Japanese car manufacturers disrupted the American auto industry in the 1970s. Everyone dismissed them at first, until suddenly they couldn't ignore the competition anymore.
The geopolitical implications are huge. Remember, these US sanctions were specifically designed to prevent Chinese companies from accessing advanced AI technology. But instead of slowing them down, it might have actually forced them to innovate in ways that give them an advantage.
It's like that old saying about necessity being the mother of invention. They had to figure out how to do more with less. And in doing so, they might have discovered a better way forward.
Imagine a computer system so massive it consumes the same amount of power as 20,000 homes. That's what's powering Grok 3, and it might just revolutionize how we interact with artificial intelligence.
The scale of this operation is mind-blowing. We're talking about 200,000 GPUs running 24/7 in that Memphis facility they're calling the Colossus supercomputer.
Well, what's fascinating is that this isn't just about raw computing power. It's an entire ecosystem of AI models. You've got Grok 3, reasoning for complex problems, Grok 3 Mini for lighter tasks, and several variations in between.
So how exactly are they implementing these different models? I understand there's something called chain of thought prompting.
Think of it like watching a master chess player explain their strategy. The AI maps out its reasoning process before giving an answer, though interestingly, XAI has deliberately hidden some of these thought processes to protect their intellectual property.
The way they're positioning themselves against competitors like OpenAI and Google seems pretty bold. claiming they're outperforming them in mathematics and scientific reasoning.
And here's where it gets interesting. They're backing these claims with specific benchmarks. Grok 3 is reportedly excelling in tests like AIM for mathematics and GPQA for PhD-level scientific questions. Even their smaller models are performing impressively in head-to-head competitions.
The pricing structure seems ambitious, though. $30 monthly for Super Grok. What features justify that price point?
Well, they're rolling out some pretty impressive capabilities. There's Deep Search, which can analyze both web content and X data for detailed summaries, and Big Brain Mode for complex problem solving. Plus, they're about to launch voice interaction features.
The development timeline is incredibly aggressive. How are they managing to implement changes so quickly?
That's where the massive infrastructure investment comes in. They're finalizing a $5 billion deal with Dell for AI-optimized servers, and they're part of a broader industry push that could see up to $500 billion invested in AI data centers across the U.S.
Hmm. The financial scale of this AI arms race is staggering. What's driving all this investment?
It's really about securing a position in what could be the next major technological revolution. XAI is seeking $10 billion in funding at a $75 billion valuation, while OpenAI might hit $300 billion. And let's not forget the recent drama with Musk's lawsuits and that $974 billion offer to buy OpenAI's nonprofit arm.
The practical applications seem vast. What sectors do you think will be most impacted?
Initially, we're looking at finance, software development, and scientific research. But with their upcoming enterprise API, we could see Grok 3's capabilities integrated into everything from medical diagnostics to educational tools.
The ethical considerations must be significant. How are they handling issues of bias and content moderation?
That's been an evolving story. While they initially promoted Grok as being more unfiltered, they've had to balance that with responsible AI development. Musk attributes current limitations to inherent biases in training data, but they're working toward what they claim will be true political neutrality.
Looking ahead, what should we be watching for in the next few months?
Three key things. First, the rollout of their voice capabilities and how that changes user interaction. Second, the impact of their enterprise API on business applications. And third, how they handle the eventual open sourcing of Grok 2 once Grok 3 is fully stable.
The pace of development is remarkable. Do you think they can maintain this momentum?
Well, with their massive computing infrastructure and aggressive development timeline, they're certainly positioned to keep pushing boundaries. The real question is how they'll balance rapid innovation with practical usefulness and responsible development.
This really feels like a turning point in AI development.
Indeed, and what makes Grok 3 particularly significant is how it represents the convergence of massive computing power, sophisticated AI architecture, and practical accessibility. We're watching the future of human-AI interaction take shape in real time. The world's most powerful AI systems run on technology that started with three guys dreaming about dinosaurs in a Denny's restaurant. That might sound crazy, but NVIDIA's journey from gaming graphics to powering ChatGPT is one of the most fascinating pivots in tech history.
You know what's incredible about that? Those three engineers were really just trying to make better graphics for PCs, inspired by movies like Jurassic Park. They had no idea they were laying the groundwork for artificial intelligence.
And that's what makes this story so compelling. NVIDIA's founder, Jensen Huang, basically bet the company multiple times on technologies that seemed impossible at the time. They nearly went bankrupt several times, pursuing these wild ideas.
Speaking of wild ideas, tell me more about how they went from making graphics cards for gamers to becoming the engine behind ChatGPT. That's quite a leap.
So here's where it gets interesting. In 2006, NVIDIA created this software toolkit called CUDA. For 10 years, Wall Street valued this investment at literally $0. But CUDA turned out to be perfect for parallel computing, which is exactly what you need for both gaming graphics and AI.
That's fascinating. So they were essentially building AI infrastructure before anyone even knew they needed it?
Exactly right. And when the AI boom finally hit, they were the only ones with the right technology already in place. Their A100 chips are so powerful that Microsoft needed 10,000 of them just to train ChatGPT. And get this, they don't even sell these chips individually. They come in packs of 8, priced at nearly $200,000 per pack.
The numbers are staggering. Though I imagine being at the center of the AI revolution comes with its own set of challenges.
Oh, absolutely. Their biggest vulnerability might be their dependence on TSMC in Taiwan for manufacturing. With all the geopolitical tensions between China and Taiwan, that's a serious risk. Plus, the US just banned them from selling their most advanced AI chips to China, which represents about a quarter of their revenue.
How did they handle that export ban? That must have been a massive disruption.
They had to completely re engineer their products in just a month to comply with the regulations while still serving their Chinese customers. But here's what's clever: they're already planning ahead by supporting TSMC's new manufacturing plants in Arizona.
That kind of adaptability seems to be a pattern with them. I mean, remember when their Tegra processors flopped in smartphones? Instead of giving up, they repurposed them for robotics and self-driving cars.
And now those same chips power Amazon's warehouse robots. It's like they have this uncanny ability to find new uses for their technology. They're even working on something called the Omniverse now, which has over 700 customers using it for everything from car design to wind turbine optimization.
That's quite a journey from making graphics cards for gaming. Though I imagine some gamers might feel abandoned with all this focus on AI and data centers.
You'd think so. But here's the brilliant part: all their work in AI and physics simulation actually made their gaming technology better. Their RTX graphics cards use AI to fill in 7 out of 8 pixels in real time, making games look more realistic than ever.
So everything they develop ends up feeding back into their other technologies? That's pretty impressive strategic thinking.
And it all comes down to Jensen Huang's leadership. He's one of the rare Silicon Valley founders who's still CEO after 30 years. He immigrated from Taiwan as a kid, studied engineering, and just kept betting on the future even when nobody else could see it.
That persistence really paid off. They're now one of the 10 most valuable companies in the world, right?
That's right. And they're still taking huge risks, like developing their own data center, CPU called Grace, to compete with Intel and AMD. It's pretty remarkable when you think about it. They could have just stayed comfortable making gaming graphics cards.
Instead, they're powering everything from climate modeling to drug discovery. It's amazing how many different industries now depend on their technology.
And that might be the biggest lesson from NVIDIA's story. Sometimes the most valuable innovations come from betting on possibilities that others can't even imagine yet. They saw the potential of parallel computing when everyone else was focused on traditional processors.
Looking ahead, what do you think their next big bet will be?
Well, with the Omniverse, they're essentially trying to build the infrastructure for the metaverse before everyone else. But knowing NVIDIA, they're probably already working on something we can't even conceive of yet. That's been their pattern: seeing around corners and preparing for futures that don't exist yet.
From Denny's to dominating AI. Now that's what I call playing the long game.
And to think it all started because 3 engineers wanted to make dinosaurs look more realistic on a computer screen. Sometimes the biggest technological revolutions come from the most unexpected places. Imagine being told you're going on an 8-day business trip that suddenly turns into a 300-day stay. But that business trip is to space, and your ride home just became the center of a massive political controversy.
That's such a wild situation for these astronauts. And what makes it even more fascinating is how this whole story just exploded after that Fox News interview with Elon Musk.
You know what's really striking about this? The sheer contrast between NASA's official stance and what Musk is claiming. He's essentially saying these astronauts were left up there because of political grudges.
Well, let's break down what we actually know about the situation. These astronauts, Butch Wilmore and Suni Williams, were supposed to be part of a routine mission, right?
Exactly. They were meant to be up there for just over a week as part of Boeing's Starliner program. But here we are, nearly 300 days later, and they're still orbiting Earth, while a social media war erupts below them.
The way this is playing out on social media is fascinating. I mean, we had Andreas Mogensen, an actual ISS commander, calling Musk's claims a lie in real time.
And that's where things got really heated. Musk fired back, saying SpaceX could have brought them back months ago, claiming he'd made a direct offer to the Biden administration that was refused.
So, what's interesting here is how different parties are interpreting the same situation. Dr. Phil Metzger suggested it was more about NASA's complex relationship with Congress and budget constraints.
Right? But then Musk dropped that bombshell, claiming it wasn't about PR or budget at all. His exact words were that the real issue is that they did not want positive press for someone who supported Trump. That's a pretty serious accusation.
Hmm. And this raises some really important questions about how space exploration decisions are made. How much is truly about technical capabilities versus political considerations?
You know what's particularly fascinating? The money aspect. We're talking about a potential rescue mission that would cost around $200 million. That's not exactly pocket change, even for NASA.
Well, that brings up an interesting point about the economics of space rescue missions. Has there ever been a precedent for this kind of situation?
Actually, there have been several extended stays on the ISS, but what makes this one different is the public controversy surrounding it. And then, as if this wasn't dramatic enough, Musk suggests deorbiting the entire ISS in 2 years.
That suggestion about the ISS seems almost like a provocative response to the whole situation. I mean, we're talking about decommissioning a $150 billion space station years ahead of schedule.
And here's what makes that suggestion even more complicated. There's currently no commercial alternative ready to take the ISS's place. We're looking at potentially losing our continuous human presence in low Earth orbit.
The timing of all this is pretty remarkable, too, isn't it? Just as SpaceX is preparing for their next Starship flight, potentially as soon as February 26th.
You know what's really striking about this whole situation? It's showing us how space exploration has evolved from being purely about scientific achievement to this complex web of commercial interests, political considerations, and public relations.
That's such an important point. We're watching the growing pains of this new era in space exploration play out in real time on social media.
And let's not forget the human element in all of this. These astronauts have families who were expecting them home months ago. Whatever the political or technical reasons, that's a massive disruption to their lives.
The psychological impact must be significant, even for trained professionals. How do you mentally prepare for a mission that keeps getting extended indefinitely?
Well, historically, astronauts have shown remarkable resilience in these situations. But you're right. There's a big difference between volunteering for a long-duration mission and having one thrust upon you.
And this whole situation might affect future astronaut recruitment too? Who wants to sign up for a mission when the return date seems so uncertain?
That's a crucial point. This could have long-lasting implications for how NASA and commercial space companies handle crew assignments and mission planning in the future.
So, what do you think this means for the future of space collaboration? This very public dispute can't be good for relationships between these various space entities.
Well, I think we're seeing the messy reality of what happens when you have multiple players, government agencies, private companies, international partners, all trying to work together in space. It's like a complex dance where everyone needs to move in sync, but sometimes they step on each other's toes.
The transparency of it all is pretty unprecedented, though. We're watching these debates unfold in real time.
And that's both good and bad, right? On one hand, we get to see how these decisions are really made. On the other hand, it might make it harder for these organizations to work together effectively when every disagreement becomes public.
Looking ahead, what do you think this means for the immediate future of space exploration?
I think we're at a crucial turning point. This situation is forcing us to confront some really important questions about how we manage space operations in this new era of commercial spaceflight. And with Starship tests on the horizon and plans for Mars missions in development, these questions need answers sooner rather than later.
That's a lot to think about. It really shows how space exploration isn't just about the technology anymore.
Exactly. It's about politics, economics, public relations, and human psychology all wrapped up together. And as we push further into space, These challenges are only going to become more complex. The world's most powerful AI company just admitted they got it completely wrong. OpenAI's Sam Altman dropped a bombshell that's shaking up the entire artificial intelligence industry.
That's such a stunning admission from a company that's basically defined AI development for the past few years. What exactly prompted this revelation?
Well, it came during a Reddit AMA where Altman said they need to completely rethink their approach to open source AI. For a company that built its reputation on being at the cutting edge, that's a massive shift.
The timing of this confession is fascinating, especially with companies like DeepSeek breathing down their neck.
Speaking of DeepSeek, their R1 model is doing something remarkable, showing every single step of its reasoning process. That's in direct contrast to OpenAI's traditional black box approach.
And that transparency is really resonating with researchers and developers, isn't it? It must be putting enormous pressure on OpenAI.
You know what's even more interesting? OpenAI has actually accused DeepSeek of stealing their intellectual property to catch up, though they haven't provided any concrete evidence.
That's quite an allegation. It really shows how threatened they're feeling by these newer players in the space.
And it's not just DeepSeek. Meta's Llama 3, Anthropic, and Mr. R AI are all making huge strides. The days of OpenAI's comfortable lead seem to be over.
Let's talk about the economics here. OpenAI is investing billions in infrastructure, including this massive Stargate data center project. How sustainable is that?
That's the thing. They're already losing money on ChatGPT's Pro plan, which costs users $20 per month. And get this, Microsoft has poured over $13 billion into OpenAI, with more funding likely needed.
So they're promising to make ChatGPT cheaper while their costs are skyrocketing? Something doesn't add up there.
Exactly. And here's where it gets really interesting. This push for more computing power isn't just about better chatbots. They're in an arms race for what they call recursive self-improvement.
That sounds ominous. What exactly does that mean for practical applications?
Well, imagine AI systems that can optimize and improve themselves faster than humans can understand or control. That's why governments are starting to pay very close attention.
The US and UK just formed that joint AI safety task force, right? While China's implementing strict regulations on AI transparency?
Right, and meanwhile, OpenAI is diving into some really controversial territory. They just announced a partnership with U.S. national laboratories for nuclear defense research.
That's a concerning combination: advanced AI and nuclear technology. How are they justifying that kind of collaboration?
Their chief product officer, Kevin W., says they trust the government scientists involved. But many experts are raising red flags about the potential risks.
It seems like OpenAI is trying to maintain this delicate balance between pushing boundaries and maintaining safety. How successful have they been?
Well, that's the million-dollar question. Or should I say, billion-dollar question. They're trying to be the responsible leader in AI development while simultaneously racing to stay ahead of competitors.
And now, with Altman admitting they were wrong about open source AI, does that suggest a major strategy shift is coming?
Here's what's fascinating. They're talking about open sourcing older models, but keeping their cutting-edge technology proprietary. It's like they're trying to have it both ways.
That halfway approach might not be enough, though, especially with companies like DeepSeek and Meta making their latest models completely open source.
And let's not forget about GPT-5. While there's no official timeline, the pressure to deliver something groundbreaking is intense.
Especially with their O3 reasoning model going head to head with DeepSeek's R1, right?
Exactly. And in the image generation space, they're already playing catch-up to Midjourney 6 and Stable Diffusion XL. The competition is fierce on every front.
It's remarkable how quickly the landscape has changed. Just a few years ago, OpenAI seemed untouchable.
And here's what I find most intriguing. Altman's prediction that when we achieve AGI, the world will only have a 2-week freakout before going back to normal.
That seems incredibly optimistic given how much impact current AI systems are already having on society.
It really does. And with the computing power they're building through Stargate, We might be closer to testing that prediction than many people realize.
The scale of these developments is staggering. How do you even begin to ensure safety at this level?
That's precisely why their nuclear research partnership has so many people worried. We're talking about combining two of the most powerful and potentially dangerous technologies ever created.
And all while trying to maintain their market position, manage costs, and fend off competitors. It's a lot of plates to keep spinning.
You know what this reminds me of? The early days of social media, when companies were moving fast and breaking things. Except now, the stakes are exponentially higher.
That's a chilling comparison, considering how that turned out.
And here's the kicker: OpenAI might not even have time to learn from those historical lessons. The pace of AI development is just too rapid.
So, what do you think this means for the future of AI development?
Well, I think we're at a crucial turning point. OpenAI's admission about getting it wrong on open source could be the first domino in a much larger transformation of the AI industry.
And whether that transformation leads to more open, transparent AI development or something else entirely remains to be seen.
Exactly. The next few years are going to be critical. And one thing's for certain: the AI landscape we see today won't be the one we're looking at in 2025. The world's most advanced AI just solved complex orbital mechanics problems on the fly. But what's even more remarkable is that it did this while explaining its thinking process step by step, like a brilliant professor teaching a master class.
You know what fascinates me about these Grok 3 results? The way they tested it in that chatbot arena. It's like a double blind study where people had no idea which AI they were evaluating.
That's exactly right. And under the codename Chocolate, it didn't just win. It absolutely dominated with an unprecedented ELO score of 1,400. The fascinating part is that score keeps climbing higher every day.
Well, that brings up an interesting point about continuous improvement. From what I understand, users can actually see noticeable differences in its capabilities within just 24 hours of use.
The speed of improvement is staggering. Just think about this. Only 17 months ago, their earlier models struggled with basic high school problems. Now they're saying these academic benchmarks might become too easy to even be useful metrics.
That's quite a leap forward. Could you break down those three main testing areas they focused on?
So they really put it through its paces. We're talking about high school competition math problems, PhD level science questions, and competitive coding challenges. But here's what's really interesting: they didn't just test it on existing problems.
Hmm. You're referring to that AME 2025 exam test, right? The one that was literally just released?
Exactly. They took this brand new exam, just 5 days old, and Grok 3 actually performed better on it than on older material. This wasn't just pattern matching or memorization, it showed genuine understanding and ability to generalize knowledge.
You know what really drives that point home for me? That unscripted demonstration where they asked it to calculate a spacecraft trajectory between Earth and Mars.
Oh man, that was incredible. Not only did it write the code from scratch, but it incorporated actual physics principles, Kepler's laws, and created a working simulation that SpaceX engineers said was surprisingly accurate. And it did all this while showing its work step by step.
The transparency aspect really sets it apart, doesn't it? Especially with that new deep search feature they're rolling out.
Well, let me tell you why that's such a game changer. Instead of just getting an answer, you can actually see how the AI reached its conclusions. It shows you which sources it consulted, how it verified information, and even how it cross-referenced different websites to ensure accuracy.
That must save an enormous amount of research time.
We're talking about condensing hours of research into minutes. And here's what makes it even more powerful: you can actually guide it. You can tell it which sources to prioritize or avoid, making it more like a highly efficient research assistant than just another search engine.
So, what kind of real world applications are we looking at here?
Well, think about this. It could help researchers parse through massive amounts of scientific literature, assist engineers in complex calculations, or even help regular users find accurate information about current events. But what's particularly interesting is how they're handling the rollout through their new website.
Though, from what I understand, that website launch didn't quite go as planned.
You know what's funny about that? Even the world's most advanced I couldn't predict how many people would try to access the site at once. But once it's fully operational, Grok.com will offer the most advanced features, with the iOS app providing a more streamlined experience.
The continuous improvement aspect really stands out to me. How do you think this might change the landscape of AI development?
Well, consider this. We might be approaching a point where traditional benchmarks become obsolete. Instead of measuring AI capabilities through test scores, we might need to start evaluating them based on their ability to make novel scientific discoveries or engineering breakthroughs.
That's a fascinating perspective. So, we're potentially moving beyond academic metrics entirely?
Exactly. And what's particularly interesting is how they're balancing these advanced capabilities with practical accessibility. Whether you're a quantum physicist or someone trying to plan their weekend, they're building tools that can adapt to your needs.
The implications for education and research must be enormous.
Oh, absolutely massive. Imagine having access to not just information, but understanding. It's like having a brilliant mentor who can explain complex concepts clearly and show you exactly how they reached their conclusions. This could revolutionize how we learn and solve problems.
Though I imagine this raises some interesting questions about the future of certain professions.
Well, here's what's fascinating about that. It's not about replacing human expertise, but augmenting it. Think of it like having a calculator that can also explain calculus. The tool doesn't replace the mathematician, it helps them work more effectively.
That's an interesting way to look at it. How do you see this developing over the next few years?
Looking at the rate of progress, we might see capabilities in the next 17 months that we can barely imagine now. But what's really exciting is how this technology might help us tackle some of our biggest challenges: climate change, medical research, space exploration.
So it's not just about making existing tasks easier, but potentially enabling entirely new discoveries?
Precisely. And what makes this particularly exciting is the combination of raw computational power with this new ability to reason and explain. It's not just about finding answers anymore, it's about understanding the process and being able to apply that understanding to new challenges.
That really changes the game in terms of how we might approach complex problems.
You know what's really going to be interesting to watch? How this technology might change our approach to scientific research. Imagine being able to analyze centuries of scientific literature, identify patterns we've missed, and generate new hypotheses in minutes rather than years.
The potential for accelerating scientific discovery is mind boggling.
And here's what really gets me excited. This is just the beginning. We're watching the evolution of artificial intelligence in real time, and each new development seems to open up possibilities we hadn't even considered before.
Well, assuming we can keep the servers running this time.
You know what they say, even the smartest I still needs good old-fashioned infrastructure. But jokes aside, this really feels like a pivotal moment in technological history. We're not just watching AI get better at tasks. We're watching it develop true understanding and the ability to share that understanding with humans in meaningful ways.